So we just got done talking about work and power, and now we're going to move on to our next concept, which is energy. We're going to be looking at the two types of energies and how to calculate them. The first type of energy we can look at is potential energy. This is stored energy due to an object's position, and we can think of this potential energy as like a wrecking ball. If you pull back a wrecking ball, you're gaining potential energy as you pull it back, along with looking at a bow and arrow. As you pull the string back on a bow and arrow, you're going to be gaining potential energy for that arrow. Again, it's only stored energy. It's not yet used, so it's just the potential to have that energy. Then we can look at gravitational potential energy. This is potential energy due to an object's gravitational pull, which we see on Earth as gravity, and it's looking at the position, the vertical position of the object. And this is going to be directly related to an object's mass, meaning the more mass you have, the more gravitational potential energy you will have. And it also is directly related to the height, meaning the more elevated you are, the more gravitational potential energy you'll have as well. So since gravitational potential energy is directly proportional to height, if you double the height, then you double the gravitational potential energy. If you triple the height, then you will triple the gravitational potential energy. So as you increase one, the other will increase as well. And you can look at this picture of a boy on a swing. As he is higher on the swing, he's going to have more potential energy, and as he's lower on the swing, he will have less potential energy. So the formula that we're going to be using to find potential energy will be the mass times gravity times height. And the unit we're going to be using for potential energy is joules, which does look a little bit familiar because we used joule as a unit for work. And so we'll talk about this a little bit later, but in order to do work, you must have energy. So they're directly related in that sense. And the more massive an object has, the more gravitational potential energy it will have, like we said before. And again, the higher the object, the more gravitational potential energy it has. So looking again at the formula, the mass, that will be measured in kilograms. Gravity is going to be 9.8 meters per second squared. And then height will be how high it is from the ground. So here's a practice that we're going to be looking at. So if we have a ball up here and it has 50 joules of potential energy, we can use that information to fill out everything else in this graph. So let's look at this ball right here. So at the bottom, we're going to be looking at the potential energy of this ball. At the top, again, it had that 50 joules of potential energy, and then at the bottom, there is no height, meaning it lost all its elevation, so the potential energy right there would actually be 0. There's no more potential energy for it to have. The height is 0. Anything times 0, you will have 0 joules of potential energy. And we see that as well over here. It says 0 joules of potential energy of the ball that way. Because again, there's no elevation, there's no height. So E would also be 0 as well. So any ball on the ground would have 0 joules of potential energy. Then we can look at D. D is on the first step. So it's gaining height, meaning it's going to be gaining potential energy. And if you look again up here, this 50 means that is the max potential energy this ball will have. And there are 5 steps. So essentially, every step, it's going to be gaining a fifth of that potential energy. So that means that this D is going to have 10 joules of potential energy. And then as we go up a little bit higher on C, it's going to have 20 joules of potential energy. And looking at B, it's going to have 30 joules of potential energy. Looking at A, it's going to have 40 joules of potential energy. So again, as you get more elevated, you get more potential energy. And then as you come down, as the height decreases, your potential energy will also decrease. So now we're going to look at kinetic energy. This is energy of motion, meaning the object must be moving in order to have kinetic energy. And there's going to be two main things that we look at. We're going to be looking at the object's mass and its speed. So the formula for kinetic energy is mass times the velocity squared over 2. That is the formula I usually use. You can also use 0.5 times mass times velocity squared if that is easier for you. But the main thing when solving for kinetic energy is you need to know that velocity is the only variable that gets squared, meaning you should square velocity first before doing anything. Do not wait to square your answer because that will be wrong. Again, the only thing squared in this formula is velocity. The unit for kinetic energy would be joule, just like potential energy, just like work, they're all joules. And it's going to be directly proportional to the square of its velocity. So usually when we say if you double velocity, you double the kinetic energy, this is not true. If you double velocity, that means you get 4 times the kinetic energy, meaning whatever you do to velocity, so let's say again we double it, you have to square that. So 2 times 2 will be 4 times the kinetic energy. If you triple the velocity, you're going to have to square that. So 3 squared is going to be 9 times the kinetic energy. And if you quadruple, that's 4. 4 squared will be 16 times the kinetic energy. So again, kinetic energy is directly proportional to the square of its velocity. So we're going to look at a couple examples. So we have the kinetic energy, or we're looking for kinetic energy of a 500 kilogram car, has a speed of 10 meters per second. Again, kinetic energy is going to be mass times velocity squared over 2. So we're going to plug in what we're given. Our mass is 500, our velocity is 10, and we square that. And we're going to divide by 2. So again, the first thing you do is you square your velocity. So you're going to get 100. 10 times 10 is 100. And then you're going to multiply your mass by your velocity squared. So 500 times 100 will give you 50,000. And then the last step is divide by 2. And you're going to get 25,000. And again, the unit for kinetic energy is joule. Then it asks, the same roller coaster as before is now going twice the speed. What would be the new kinetic energy? So you can plug in the kinetic energy as 20, or if you know the rule, if you double the speed, then you're going to get 4 times the kinetic energy. So 4 times that 25,000, and you're going to get 100,000 joules. Again, if you would like, you can plug that into the kinetic energy formula, and you should also get 100,000 joules as well. Another problem we have is a bowling ball has a kinetic energy of 10,000 joules. Prior to hitting the pins, if the ball's mass is 20 kilograms, what is the speed? So I've given you the formula rearranged to find velocity when given kinetic energy. So your velocity is going to be the square root. Your kinetic energy is that 10,000. You have 2 up top. And then your mass down here will be 20. So the first thing you're going to do is you're going to multiply your kinetic energy by 2. So 10,000 times 2 will give you 20,000. And then you're going to divide that number by 20. And you should get 1,000. And the last step is to take the square root of 1,000, and you should get 31.62, and since it's looking for velocity, it'll be meters per second, and that is your answer. So that is it for notes today. What I'm going to have you do now is work on the practice worksheet that I provided, and then I will provide you with a video of me doing the problem so that way you can check your work. That is it.